Hello everyone, welcome all on Data Phoenix webinar. Today with us Andrei Lopatenko, and we will speak about evaluation LLMs for production system. Andrei worked in different companies, in Apple, in Google. Also, last company in which he worked was Zillow, and he have a very big experience with machine learning system and LLMs as well. I will give the microphone to Andrei. I will want to say you that you can ask the question using Slando. The link we share in the chat and under the video. So please write your all question on Slando, and at the end of Andrei's presentation, we will answer for all your questions. And don't forget to join to our Slack channel where we can continue discussion about LLMs and other topics. So I give the microphone to Andrei, and we will start.
Hello, everyone. Dmitros, thank you very much for inviting me here. I'm very honored to present to this audience. Thank you very much for this opportunity. And yeah, hello, everybody. So let me start presentation. So today we're talking about evaluating LLM models and production system based on LLM systems. I'm taking very pragmatic approach, not just talking the best academic results, but what really useful once you're developing LLM applications for you inside your companies, inside your settings. Why I believe it's super important to talk about evaluation. Greg Brockman during ChatGPT launch correctly noticed that evals are surprisingly often all what you need. And I can give you example, and there are many examples like that. In the early 2000s, right, when I was in Google, there were several competitors to become the best, to become the most popular search engine. It was Google, Yahoo, Microsoft. And what I know from people working there, and of course from my experience, each of them had a very deep evaluation set to understand how your system works and how is it better or worse than competitors. And each of them reporting that their system better, right? And scientists in each system, of course, all of them had excellent scientists were tuning into their systems. But actually, only one of the systems appeared to be a world leader. It's Google, right? Because of better quality of search comparing to any competitors. And I believe one of the key reasons is better evaluation, because you tune all your systems to your evaluation. And if your evaluation truly reflects aligned with your customers, then you will make the best system. If it's not, you can tune your system. It could be perfect by your evaluation, but it's not what your customer wants. That's why I believe the moral of the story is evaluation is critically important for any complicated system, for any customer or business-facing system. And it will be true the same for all LLM-based systems. Would it be LLM automation system? Would it be a LLM system based for actions? LLM systems based for information retrieval? But it will be always true. Evaluation drives everything. So purpose of this presentation, I want to make it practical, right? Like there are a lot of evaluation methods developed in LLM community, but I want to talk from them from point of view, not just what's the best current benchmark to evaluate very big models, more like what are benchmarks, what are principles to use for evaluation of your systems, how you should apply to your knowledge to building your systems to evaluate for your business, for your customers, rather than some abstract evaluation methods. Again, like if you consider typical LLM-based systems now, right, of course, there is a lot of work how to create the best big model, and very few companies will work on that. So I will not focus on this first stage. But what most companies will do, you will do fine-tuning, instruct tuning. There are multiple other subtasks, how to create model best for your customers, for your tasks. And then, of course, you create system based on this model. It will be like information retrieval system, RAG-based. It can be action system when you ask system to do like based on tools, API calls, but then you create whole system around your LLM, right? And I will focus, I believe like in near future, few companies will focus on the first step of like pre-training model, but more like about second two step, how to having open source model, how will create best customer experience, best business experience for your customers and for your business, and how to test your system and tune system based for this. basically, that's what I want to emphasize, right? We're not focused on particular metrics like squat, SNLI, glue, and several other evaluation methods for the first pre-training stage. More about instruct tuning, fine tuning, training adapters is another popular methods, building LLM augmented systems, and evaluation methods. How and why we are doing what's the process of them, what evaluation methods and what evaluation software to do this later steps, which will be used in most of companies. There is a very big difference between how LLMs as foundation models used versus how traditional machine learning and data science work in many companies, right? Again, it's not like one clear cut, but there is certainly a difference like that. Traditionally, all machine learning models, they were pretty much evaluated and trained against one specific metrics and tuned for this metrics. Let's say you want to predict your own e-commerce, right, shop, and you want to predict what's the best price for your product to put on your website, right? And you have certain metrics like, is it highest probability of conversion? Is it highest revenue of the company? Some more complicated metrics, but you tune your model for that, and there is very clear metrics, right? This is typically one task, one metrics, maybe multiple tasks inside company, but more or less one metrics how you train. And it's relatively it's hard, of course, but relatively easy way to deal with traditional models. With foundation models, including LLM, and the same applies to many other foundational models in image processing, multimodal, time series foundational models now become a really important direction. You have many you have one model, right? And you have many different tasks within your company which this model is used for. And there are many metrics even with these tasks. And as of course, there is very big benefits for your company as you have one teams working on one model, improving them, and many other teams downstream tasks in different business departments, different use cases, different customer improvements get benefits from this model, but also create complexity. When you tune model to one task, even with LLM for one metrics, it's relatively easy to tune and create state-of-the-art results. The question is that you have many different subtasks and many different metrics. How you're going to progress across all of them as you improve your model, how to improve all of them. And there is a lot of research about training models. You see, it's hard task. You increase one, you degrade other. How to make consistent improvement is pretty hard, but this is one of key also evaluation. So you don't evaluate by one task, you evaluate across many tasks and many metrics. And this very typical, here's from paper, academic use. How would you use LLM for many different tasks? But actually, this is replicated in every company now. What I see with NLP cases based on LLMs, perhaps you will not use all of this, right? But it's very typical for many companies have diversity of tasks. And the same also diversity of semantic areas, right? Let's say your e-commerce shop or real estate company or something else. You will have very different subdomains. It can be shopping experience, it can be financial experience, it can be something else, where model have very different behavior. And as you build evaluation suits for your company, it becomes really important to be sure that you will cover many of these areas, not just focus on one, because model behavior can be very different across many different cases. Again, given typical example within company, you will not have this huge coverage of NLP cases, but certainly summarization, classification, question answering, natural entity extraction, different query understanding tasks, different item understanding tasks will be used. The same model will be used for them within your company, right? And many different teams will use this. And frequently these teams will be very different departments. So as you're working on progress of fine-tuning, instruct tuning, and other of your model adapters training, it's important to build evaluation set such that will cover this very big variety of different tasks, and you will not overtune model for a particular task, because many customers inside company, many customers externally will be using this, and this is very important requirement to evaluation sets which you build for model evaluation now. And there are many other important differences which makes LLM for evaluation different from classical model evaluation, because LLMs naturally, due to the size of the model, right, by complexity expose many different behaviors. So if you predict, say, if you design time series model, it's pretty clear. You have a time event, you want to predict next one within certain period of time, you want to predict best price. pretty clear model capability evaluate. The problem with LLMs, they have many different properties. They have encoded knowledge, right? When you ask an LLM on its own, like tell me something, it has encoded knowledge, which inside through like generative task, it exposes knowledge. But you have also reasoning, right? Because they don't only respond with knowledge they also capable perform multiple different chain techniques, multiple different types of techniques. They perform pretty complicated reasoning on its own. Another and you want to evaluate all of these tasks, right? You don't evaluate just one of them. You want to evaluate different capabilities of LLM at different levels. Another high risk LLMs, if you have model price prediction model, of course, price is shown to user, but it's limited context. With LLM, outputs are frequently directly exposed to customer or business experience through conversational experience, and of course, risk function is high because if you have some toxic response or some racial, offending response or something else, is directly goes to the customer, very high risk, right? You saw this with Google Gemini recently, when they have this very biased image, and it got huge public attention. Was immediately exposed everywhere, and it was happened with multiple chatbots previously when a model makes some output which directly exposed to the customer, and if this output is wrong, not just factual answers are very unpleasant. There was a case recently, Canada airline company has to pay to customer because their model predicted making correct financial advise them incorrect decision, and customer make incorrect financial decision, right? Knowledge, reasoning, complexity of LLMs, but also direct exposure to many customer experience makes evaluation much more important. Emerging behaviors, sometimes you have unpredictable behaviors of LLM which you don't know before how to evaluate them equation. And of course, complexity of LLM output. It's not like when you predict price, you have just one number. You have whole text, right? And how to evaluate this text, because is this answer is correct or not, right? There are a lot of paraphrasal capability, how to evaluate LLM, also in its statistical model, it's changed over time, but your evaluation, you must understand all different phrases to express the same answer, must understand that maybe you changed output, but actually it's the same from semantic point of view. So there are a lot of questions, there are a lot of problems how to build LLM evaluation based on this complexity of LLM. Naturally hard, right? There are even more complex reasoning task, multi-turn task of LLM, instruction following, and you can follow. There are a lot of really good papers which describe how to build evaluation for those. But what I'm trying to say, such that in your particular use cases you built, in your business applications, in your customer-facing applications, besides basic LLM functionality, I will describe a little later, evaluation task for those, can be many different, actually much more complex tasks, such as reasoning, multi-turn conversations, much harder to evaluate than just direct question answering. And there is a lot of work in academic community to evaluate those tasks, and a lot of this work is actually applicable in industrial settings. Why to evaluate? Another important question. There are different reasons. First, of course, you'll create a new model launches. You want to understand, will they improve your product, right? Will they improve your customer experience? Is it good to launch or not? Will be better user experience? Will be better impact on business, higher conversion of customers, higher inside business conversion? Will the system, will the experience become better? So validation of model improvements is of course important for any AI-driven application, right? New product launches, you're going to launch a new product. And a good example would be, again, coming back to Google, right? With the new launch of image generator. Is this product ready to launch or not? Is there something what you can expose your customers to which they will not like? Is it something toxic, offending or something else, right? To understand if your product launch is well aligned with customers, and for this you need to evaluate your LLM, and not only LLM, but whole end-to-end product, right? And again, validation coming back. Another is really important role of evaluation, coming back to that my first slide when I talk about Google competing versus other companies. In any modern AI, machine learning driven system, evaluation is driving whole system development. Your system improves, of course, there are multiple different components you improve, But typically, evaluation defines what's the next step of the system, because you tune your system, you tune your models to new two parameters, which you like how you evaluate your models, you improve your metrics, right? This is how you train your system, to metrics you train them. And right evaluation drives development of the system, wrong evaluation drives wrong development of the system. And that's why it's really important to define evaluation for your system, because it will drive not only evaluation, but it will drive whole system development. System will be developed as you evaluate this. And this is really important to understand for any AI-driven system, but especially for LLMs. And that's why so much importance to evaluation, because it will define what the future of your system is, it successful or not. Important to understand, again, typically academic benchmarks focus on one or another type of average case scenario, right? But of course, it's like for your customer or business-driven system is not enough. You must understand worst case behavior, you must understand average case, you must understand best case, because that's the way how people judge the system, how that's the way people understand the system, either they like the system or they repel and then don't use system. There are many different cases, like when maybe average case is good, but maybe you will just promote some explicit queries for audience which you don't want to show explicit queries. Like even the average case is improved, you cannot afford this. You must understand worst case behavior, and frequently it's prohibitive, right? Even average case sort of improving, but worst case is hurt, so you don't want to go there. So as you build LLM evaluation systems for your customers, for your business, it's really important to understand all these cases, not just to build some benchmark and let's tune for average case. What will be worst case? What will be best case? What I must follow? Comply. Many industries by compliance regulated, so all of this must be understood, right? Risk estimates are really important to understand, right? Worst risk, what's the impact, and again, like LLM used for many different cases. Inside company will be used in every company for many different cases. Important to have this full semantic coverage, right? Every company has multiple different departments, multiple different customer cohorts, multiple different products. And typically, like LLMs will not be driven inside of each of them. There will be one or few LLMs driving whole company. And it's important as you build LLM evaluation to build coverage, both functional and semantic, to cover whole your company. Very similar to evaluation of search engines, right? I remember when I came to Google in 2000s, early 2000s, I was really impressed how complex evaluation. And I see this is, and many kind of AI systems have much simpler evaluation, but for LLM is necessary due to natural complexity of LLM models and LLM systems. Again, LLM evaluation in many companies will be continuously driven process, right? So you don't you continuously train, retrain, create better models for the company, right? And many people also work on that, because there are many aspects you can do, how many scientists will work in your company to improve LLMs. And most likely also there will be some cases it will be not as many LLMs as models, right, in traditional machine learning, because LLM will be used by many different, but most probably there will be not one LLM. Because there are naturally, if you want to build conversational experience, typically you need to go to those very big LLMs, up to 70 billion. Now there are a lot of good experiments with smaller set of parameters, but certainly to do conversational experience, you need big LLM, a large LLM by number of parameters rather than LLM to do summarization or natural entity extraction and some other classification tasks, right? But it becomes very expensive to use this LLM due to cloud and other costs and latency, and most probably will have different LLMs to cover those different cases in many companies. And there are many other different requirements for LLMs, of course, like different use cases. So I expect in many big companies, at least, you will have few LLMs, several LLMs serving different products, different use cases, due to very different requirements. But still, each of these LLM will serve multiple products, multiple use cases. Each of them will be used by multiple different teams in company. And improvement each LLM leads to many downstream improvements. So a very high ROI on LLM improvements across whole company. So which will necessarily require a continuous process, how to evaluate your LLM, how to improve this, because continuous process will be continuous. Like every change, 1% improvement will give a big benefit for your business. So to do this, to enable this like improvement, your evaluation process must be fast and cheap, such that if you have like 100 scientists working lemons, they have new ideas to test them, must be very fast. Does my improvement works or not? Evaluation metrics must be correlated with customer and business metrics. I think it's really important, right? Rather than abstract, and it's a lot of academic metrics not necessary. That's why important to develop your own metrics. And again, evaluation must cover different aspects of use of LLM across whole your business. And of course, it's not only standard task, but task specific for your business. What a semantic categories it cover, what NLP metrics important for your business, it must cover and must be tested against. So what I believe necessary requirements for the evaluation: alignment. So each atomic measurement must be aligned with your customer business demand. Representation, a set of whole metrics must represent the whole process. So like sampling of your trail, like testing set, weighting, aggregation must represent whole population. So not only atomic measurement aligns, but also whole your evaluation set aligns with your company business or customers. Systems, of course, systems must be fast, must be cheap, must not be obtrusive, must get evaluation results fast. And statistics, a lot of work how to do right evaluations through smaller sample set, because like how to make them fast, how to make them interpretable, those kind of 4 necessary dimensions of good evaluation. So this more like I talk about high level I believe principles, what evaluations should, evaluation process should be defined for LLM, and I see it's pretty consistent across different companies and pretty consistent demand. Let's go to some particular methods which can be used for your cases. So I will describe how LLM evaluated for different LLM tasks. And again, I'm focused not on particular method, but more like what you can use, how you can use the principles behind this method, what's good, what's bad, such that it can be used in your company for tasks which are in your company. So LLM embedding, right? Typically, like if you go, like I will come back, there are 2 different tasks, kind of like 2 different types of tasks LLMs are used for. One is generative tasks, right? So how to generate using how to generate text for particular tasks, again, conversational experience, summarization, many other. How to create text. Another is how to create embedding. So given a text, it will be query, it will be paragraph, it will be something else. How to create multidimensional representation of this chunk of information. And typically, like currently, there is some new work from this paper when they built LLM, which is reasonably good for both of the tasks, but typically those 2, actually this is a good example why you will need most probably several LLMs within your company. But so there are like embedding tasks and generative tasks. And embedding task, perhaps like both of them very important. And I see perhaps embedding tasks will be a little bit less important. It's again arguable, it may depend on business or company, but will be one of the most important LLM application as they need it for many high impact use cases, search, recommendation, question answering system, because typically for most of modern businesses, search and recommendations driving very big part of business revenue. And of course, improving those systems by using LLM embeddings has big impact on your system, right? So embeddings are really important and will be very big due to direct connection to company revenues and most companies. And embeddings are used for many different customer-facing tasks, for many different type of entities, many different modalities, many different fundamental tasks such as ranking, retrieval, clustering, text similarity. So even coming to embeddings on its own, we're getting this very multidimensional measurement when we don't have like, is it embedding good or bad? What give me total number? They may be good for certain tasks, not so good for other tasks. And it's important even in such tasks, subtask of LLM evaluation to have multidimensional evaluation. How do you improve your LLM generative embedding system? A good example is MTEP, is massive text embedding benchmark. It's popular academic benchmark. It's a benchmark, but also a suite of open software which you can use and which is quite flexible, which is good enough. So here's like when you can get this. And I think it's a good example because it shows you there are multiple different core embedding tasks by text mining, classification, clustering, pair classification, re-ranking, retrieval, semantic text similarity, summarization, and this and it's open source software. And again, this is typical use. Again, these tasks are not fully comprehensive, and most probably in your company will have something else to use Embedding for. But they give you a good kind of first evaluation. So having this test can be a very good metrics, a first evaluation to start your bootstrap. You start your bootstrap evaluation. Of course, most probably you will have different data sets which represents your systems, your customers, your data. But this is a good set to start. And they're kind of pretty standard, so I'm not going to explain now what this NLP tasks. They're pretty standard, and like NLP search tasks, but MTAP contains all of them. So what good kind of, if you look into the leaderboard, right, if you go through this, you can see like Hugging Face evaluates multiple different systems by this. You see no clear winner model across all tasks. Of course, there are models perform better if you see average score by each task. But you see, like, model behaves differently for different tasks, and it's a good something to learn that maybe in your setting it also means quite a lot, such that you will not have one model serving all of them. You may need several models serving because several different tasks may be critical, and 1% win in each of these tasks may be huge revenue gain for your company. It's kind of good justification for sometimes multi-model requirement. What I like about this MTAP as a open source, it's easy to plug in new models through a very simple API. So if you do development in your company, you tune models for your use cases. It's important to, of course, to evaluate your models. And this is easy to do this. Easy to plug in new data sets for existing tasks. You know, like again, like let's say you consider re-ranking task or retrieval task or pair classification or clustering. Of course, you don't want to do it like for kind of standard academic data. You want to do it for your system, for your customers. And you want to evaluate model behavior for your task, right? Easy to plug in new data sets. And this is good open source tools to be used by your company within your settings. And again, embeddings will be important set. And if you go how to evaluate, there are a lot of to learn from there, right? You may again use standard evaluate, like you use different metrics. You may use different weighting because your system, like let's say it represents query set, item set for your company. As actually very different, like weighting there represents your business. So it's up to you to develop this aggregation metrics, but it's good to start with this open source set. Again, you know, like there are a lot of like when they to do like information retrieval tasks, they use this pretty much standard recall at K, precision at K, and DCG at K metrics. This is one of the things which I believe in most cases is important to redefine for your business, because when NDCG was defined, I think it was in the 90s, it was defined how people use web there. And of course, now people use systems very differently. I've noticed many teams, many companies tend to kind of inherit these metrics and use them. From my observation, it's very wrong because they don't represent your customers. It's important as you build your evaluation to retune your metrics to tune systems and measure performance of system by your customers. So it's important to learn and of course to do customer research how people use your system, but it's important to retune this. And like also like this, like MWeb, they're already supported by embedding evaluation by besides MWeb, other like MLflow LLM evaluate, because it's pretty fundamental task. Embeddings are everywhere, one of important and fundamental tasks. Next slide. And of course, another critical part, I will talk later about when you evaluate LLM, it's not only about NLP performance, it's of course software performance. You know, like because embedding is one of those tasks which very much performance critical, right? Like query or your research engine, your recommendation engine will use embeddings, right? In many cases, you will need to, of course, there are a lot of caching techniques to make it better, but frequently you may use, like as your system may have 1 million queries per second with latency limits within 50 milliseconds, how to create your embedding generation will be capable to create query embedding within these limits through output and latency. Or you want to generate for every update of items, right? And you may have them 100 million updates per day. And then, so there are many different kind of practical examples, but embeddings is typically will be in those very much performance critical parts of your system when it must be extreme through output, extreme latency, and you know, as you evaluate your model, one is of course quality of embeddings, but other is like software performance of your system, of your model, how to make it possible to run these requirements, and also, of course, important to run it cheap with good cloud costs is another part of LLM evaluation. I will talk a little later more about software performance of LLM. Again, like coming back, your evaluation set of embedding, like don't use use MWeb for first, but like as you build for your company, create representation sets which represent your documents, your queries, and of course it's important to update them because every system, every customer's population change over time requirements. Like you can measure as you build your system, right? As you build your evaluation set and you use it for multiple years, it can be not representing customers anymore. So it's really important as you build this evaluation to build it changing over time. And of course, taking into account, I'm not just academic literature typically does not go into that, but once you build your search customer systems, there is a lot of subjectivity, and you must take this into account and build this into your evaluation system. Yeah, I'm again kind of coming back to LLM embeddings. Important to evaluate your model on co-embedding task, but also as you build this, build evaluation set for your whole end-to-end system, which evaluate not only embedding per se, but also like as embedding serving within your whole end-to-end stack, there will be many steps on top of it, how well the system performs. In context learning evaluation. In context learning is hard task because it requires complex reasoning from LLM. Understand task, understand examples, figure out how it works, apply to new task using only contextual cues, right? So it's hard task because of natural hard reasoning of LLM it requires. It has a lot of practical value, and there are like a very big set how to use SAL, right? And traditionally, there are many data sets which are evaluated and which are good for you, how to learn from, how you can use it for evaluation of your in-context learning for your LLMs, right? There are like Pika, HelloSwag, Lambda, several other SAL evaluation tasks. Again, SAL tasks are typically required to solve wide range of linguistic and reasoning phenomena. That's why they're hard. But another, practical use of them, because complexity of tasks they solve is also huge, right? So hard to solve, but big impact. And most probably, like many of systems, you build some financial answering system, you build some other customer support system, they will use one or another form in context learning. And there is also OpenISL framework such that you can use and build your system based on this. Is pretty flexible, it's good to use. So good example, like as you build your evaluation set for in context learning to learn systems is Pika and Lambda. Pika was about physical answers, but of course you can build for your system, which will be a very different set of question and answers, but principles are very good because it tests as you assume you build some customer support system which answer question of customers, right? It's need understanding of your business deeply instead of physical interactions. Of course, here will be your interactions for your business, but also common sense reasoning, right? And the build this Pika based is when you have answer, when you have question, and not only question, but also it can be action semantics, do something, and there are several answers from the system, which one the best. And the same you can build evaluation for your system. And it helps you to understand what problems with common sense reasoning and what problems with understanding your domain. Lambda is another system. It's multi-sentence package, a multi-passage, right? Basically, you want to complete. You have a context, you have a target sentence, and system predicts target words to complete the sentence. It also tests multiple deep comprehension of system for your business. A context-dependent language task, right? It's not like what directly measure customer experience, but it measures multiple important capabilities of your LLM, which are important to build the capabilities, functionality for your business. Ethical AI evaluation, another very hot topic, right? And again, this is very open topic. There are a lot of work being done because again, toxicity, other bias responses of LLM, wrong beliefs exposed to customer may produce very bad customer experience, very bad business experience, right? Impact is huge. Certainly, as you deploy your LLMs, as you develop your LLMs, ethical AI will be one of cornerstones how you want to protect your customers, your business against wrong misbehavior of LLMs, right? And I don't see now really good sets as ready sets to be used by you, but there is a lot of academic work how to measure, how to measure. Like for example, his work such that you can how to detect and measure beliefs in coded LLMs. There are multiple different sides of how LLM can misbehave and have a wrong ethical behavior, right? It's a very complex problem, it's naturally. But for example, beliefs, what we talk about knowledge encoded in LLM is how to detect and how to measure this. Another is deceptive behavior, right? Because behavior exposed by LLM, like toxicity, those kind of results, a little bit more simpler how to detect, how to classify them. But deceptive behavior is very harsh, right? How to detect, because even for human, like us human, they detect here deceptive behavior. Here's this paper when they describe how they do this. So ethical AI evaluation will be one of core cornerstones of your evaluation of LLMs, because you really don't want to do something wrong in that area, and it will be like a lot of needs to be built there. LLM as a judge. It's not particular evaluation methods. It's one of evaluation methods. I will use it a little later, but a classical, typical, information retrieval, other systems evaluation, models evaluation was done. Other you have some set like you want to predict price of, let's say, of certain item per period of time, right? You have historical data. You built your LLM, you built your prediction model based on your historical data, and you validate did it predicted price because you have ground truth, right? So, or you use human eval, right? And another new area with LLM is to use LLM as a judge, because it's found not for all. It's important to understand for some areas of evaluation, LLMs do quite well as when you want to judge is this good result from another LLM or not, right? It's maybe related. It's a traditional computer science problem, such that to validate something is more easy than to solve the problem, right? It's whole and P versus P. I'm just kind of giving us example. The same here. Validate answer given context. Given answer is more easy to validate is this context. Is this answer good from this context rather than generate? And there are multiple actually problems here. And again, typically you want to small LLMs solve the task because of cloud cost, latency through output. But as you evaluate this, you have opportunity to use much bigger LLM, because you don't need to run this task for billion queries per day. You want to have evaluation set, let's say, of 10,000 items, much smaller number of calls, right? Much smaller number of so it's there are different ways why you can use large LLM when you for evaluation of small LLMs. What are pros, right? Of course, automated evaluation, human evaluation is usually typically expensive because you pay to humans a certain amount to evaluate results. Much cheaper, much faster than to ask a set of humans. Flexible, complex. You can ask LLM also create interpretation of why this result is good, like why you believe the summary of this phone call is good for this particular task or not. Cons, expensive, kind of comparing. If you use large LLMs, can be expensive API calls, time, right? Again, no 100% confidence in results. Yes, LLM produce you, and you can measure, for particular task, you have good agreement with human raters. Is it true for any other task? It's not, right? So they need to be verified. But it's pretty big area such that now you can use LLM as judge, and certainly many companies will use this in there for their evaluation sets. Typically, what you do, you create a template grading task, asking using LLM as a judge, providing examples like you want to evaluate is this let's say answer is correct, answer corrected from this context, extracted from this context for this query. You give multiple examples of you put this into template, and then you provide LLM this for new tasks, right? You create the first training set, you verify the evaluation by humans. Is it LLMs doing what you expect this to do? You iterate, and several times you tune your template, and then it works, right? Again, problem if you change your LLM, it may not work as well anymore, so it's kind of continuous process. And then you run your evaluation, or you can freeze your evaluating LLM for a certain period of time. And another advantage of LLM as a judge, you can sample from live traffic, not only from training set, right? Hard to do with humans, but you can also do some sampling from live traffic and use this within your framework. And typically, grading LLM is more complex than the graded LLM. Cost evaluation can be controlled by sampling, right? By size of LLM cost, but also sampling. How you can create better statistics, better sampling techniques, such that you need smaller number of calls to evaluate the same task. You know, this is pretty big. LLMs judge may agree with human grading, but it requires work on designing and tuning grading templates. It's not for all tasks may be done, but for many tasks. Cost can be saved by using cheap LLMs, requires experimentation again a lot, so a lot of like science work, how to create better templates. Judge model can provide interpretation and explanation, which is also very useful for many grading tasks, for many LLM evaluation tasks. And for alignment with human scores, important to measure interhuman alignment, because if you measure disagreement, it's not necessarily your LLM doing wrong. Maybe a task is necessarily subjective, and LLM disagrees with some judges, just because if you ask two humans, they will disagree. So it's important, which I see in academic community, they kind of ask humans for one task, one human, and then take it as a ground truth, which is not true in industrial settings. Well, many tasks are very subjective, and humans will disagree on many of them. Evaluation of retrieval augmented systems is another important part of LLM evaluation, right? Retrieval augmented systems will be a very big part of LLM applications in industry. And again, it's retrieval of information. It's getting information. Of course, there are multiple different dimensions: correctness, comprehensive, readability, novelty, quality, factual answering, correctness, depth, many other metrics which we'll use in your system, because let's say if you're building medical answering system, and of course, authority of information will be very critical, right? You cannot give person any wrong advice of a financial system. But if you build generic chatbot for generic discussion about anything, I don't know, about shopping or something, authority maybe not so important. Again, depends on the system, right? But maybe novelty really important. If there is new product important, novelty becomes really important. So your system will have different set of requirements, and it's important to build evaluation for your system. I will come a little later. So traditional information retrieval was retrieval and ranking. Or RAG architecture is, of course, you have retrieval and then you have generator. So very different type of evaluation. Of course, frequently you have ranker inside. There are a lot of different things, but it's more like also you need to evaluate generator, which generate answer to the customers. Another, because answers generated, typically, when you evaluate, let's say, web search, you have set of links, or some e-commerce search, when you have links to products, you have products links or web links. You have very clear link. Raters grade them, right? But with generating, LLM generates different answers. But they may be semantically the same or similar, right? But you ask your raters, tell me this answer is good or not. And LLM may generate actually semantically the same answer, just different phrasing. So it's also important in evaluation of RAG systems to create the similarity scores, to understand deeply similarity scores, such that once you have a set of graded answers, you can measure new output of the system versus them, not demanding one-to-one text similarity. It must be understand all semantic difference. Typically, if you consider, I will describe now several key methods such that you evaluate LLMs inside RAG, right? Typically, what you care about, there are multiple different methods. It's what called faithfulness, answer relevance, context precision, context recall. And there are two. RAGAS is a really good framework, and open source software is used. And ARIS is new methods. I will describe the principles which most probably will be used in your system. So when you talk about RAGAS, right? So you have, what's good about this new methods, they have very little reliance on ground truths generated by human annotators, right? Here, for example, you use only to evaluate context recall. So you measure 4 metrics. Actually, there are more now if you look into RAG, but those kind of 4. Answer relevance is how this answer is relevant to this question you ask. Faithfulness is how much of this answer is generated from context generated. Is it truly corresponds to context, or LLM invented something? So hallucinations typically measure it at this point. Context precision is context retrieved, how relevant this to question. And ground truth is how much of this context relevant to truth is retrieved, is content there, right? So those 4 metrics, and 2 below, context precision and context recall, measure retrieval performance of your system, and 2 on the top, answer relevance and faithfulness faithfulness, measured generation, right? And again, hallucination is very hot topic, so it's typically measured at faithfulness step. And Sarah will discuss later a little bit more about hallucinations. Again, here, short high-level description. Faithfulness is consistency, answer with the context, but we don't have a query here. Answer relevance is answer relevant to the query. Context relevance is answer focus on the is context focus on the answer, and context all relevant sentences are retrieved. Can you generate as a good enough to generate your answer, right? So again, what important in this new frameworks, they heavily relying on LLM to evaluate your systems. So for example, faithfulness, you use LLM Pro, so you have your system which generate answers, right? And it has context, right? So what you do, you ask another LLM, you of course you need to tune prompt. I guess here comes some work from your part, how to decompose answer and context into statements, and then you use this you compute faithfulness by dividing number of supported statements versus number of total statements, right? So most of the systems is typically use LLM inside another LLM to decompose your answer into statements, into factual statements, into other statements, and then you evaluate your framework based on this. And what's good about this, you see, there is a very little human intervention needed, correctness. So basically, most of the steps can be done automatically without having human set. Human set is only needed for context recall, but most of other steps can be done automatically by LLMs on their own. Prompts should be well tuned. It requires, of course, because it may use very different LLMs for evaluation. You need to tune prompts. And what is good, this is open source framework. You can use this easily to evaluate your RAGs. And it has many more metrics as they develop, like answer critique, answer correctness. And most probably, again, in your system, you will need your own metrics. Like, let's say you want to measure novelty of answer, how to measure this, or authority of the answer, right? What's the source, how well this for this particular task. And it's important such with open source, you can easily embed for your systems, new metrics and new different evaluation criteria. ARIS is another, it's more recent work from team from Databricks and Stanford. They're doing a little bit different evaluation. They need, there are a lot of advanced also what I described in evaluation systems. You need statistical techniques. They build a system such that you need very few, 150, they report human annotations for their task. It may be different for your task, right? They evaluate more or less for the same set of metrics, kind of machine-based, when you do context relevance, answer fairness, answer relevance. And what they do, interesting, they apply quite different techniques how to evaluate this. So as inputs you need is you create a set of passages from your target corpora, right? What you evaluate your system for, a human preference validation set of only 150 annotated data points, very small set, cheap to generate. And you need 5 few short examples of so you need examples to help your LLM to generate synthetic data. I will describe steps a little later. So basically what you do, so here from the paper, the process, I will describe. First, you generate synthetic data of triples, question, answer, context, right? And you use them using your prompts which you generated, which you need to work. And then you create your prompts to create a big set of question, answer, context. And of course, you need also negative examples, and the paper they describe well how to create negative examples. Then you fine-tune LLM. It's very different techniques. So you remember previous RAGs was mostly used on prompting to split responses, but here you fine-tune LLMs to create binary classifiers for these different tasks using annotation set. Then you sample in domain query answering context triples and classify them using LLMs. And what they say, they actually observe their systems provides more better evaluations than RAGA. Also, using PPI techniques, this statistical techniques they develop, you require smaller human annotation set, which is big advantage. But also they reports that comparison of retrieval augmented system works for evaluation works better than point-based scoring due to a natural noise in what is produced here by this evaluation. And again, in most areas for your systems, if you use RAS and ARIS, they have to be customized, metrics, prompt, data sets, annotations, sampling techniques, aggregation techniques. All of this must be customized for your business. Kind of open source versions, good to start, but certainly they're not enough. Code generating LLMs, like brief description, most of it's hard task, right? Can human recognize bugs? Is generate code easy to modify, integrate? And problem of evaluation of code, code evaluation generating LLMs in code Python, C++, it's another big direction area. Well, I believe it's important for most companies, right? But not every company, not companies GitLab or Microsoft or Amazon will be creating code copilots. But what I believe, what I see, most of companies will use one or another type of action semantics. Like you will not have in LLMs only to retrieve data, right? You will have scheduling applications, routing applications, home automation, shopping applications. When you ask, I would like to buy item or do something, right? Find me like the best result out of this, and out of 3 best results, send them to my shopping cart, right? You will have action semantics in some certain domain-specific language. Can your LLM create correct action semantics? Can create correct specification of actions to do in domain-specific language? It's really important. Will be big task used by many specific tasks. So it will not generate C++ code or Python code, but most probably one or another version of domain-specific language calling external tools will be used in many companies. That's why I believe understanding how code generating LLMs evaluated is important. And there is a big shift you see with human eval. Like before, typically code was generated and then you evaluate trying to understand code on its own. Human eval pioneered that instead of evaluating code by looking into syntax, right? And there are a lot of problems how to do it properly. You ask your task to do unit tests, right? And it was, I think, will be like key for this. What you care, you don't care how it's written, you care does it produce right action. And was probably for LLMs which generate actions, which not just retrieve information, but create certain tools calls, right? It will be eval how you will do them. That's why I think something good to learn from. There are plenty of other good LLM evaluation tasks from domain specific to learn from. For example, evaluation of explanation of recommendations. Yes, you build recommendation system. Is it good? Is it good explanation or not? Do you provide to your customers why you want to do them? Pretty interesting work done in this paper, how to explain this, or health LLM recent work, how to build health prediction based on wearable sensor data is another interesting how you see how LLM applied to many other tasks. Hallucination evaluation. Another very hot topic. As you see, hallucinations is like one of the perhaps most discussed topic in LLM community, right? Because it prohibits using of LLM for many domains, many areas, and creates very bad customer experience when they already used and they do. There is Halluval set. You can look how it works and what good. And I look into this paper. And what about good? Hallucinations is very generic topic. There are many different types. They kind of select separate types of hallucination patterns, and while one understands them, it's more easy to build your evaluation framework while you understand what you want to detect, right? How to understand, how to get this, how to detect those hallucinations. And you have knowledge grounded dialogue, one type of hallucinations, text summarization, very different type of hallucinations, right? What they did in good in this paper, they detected key parts. Of course, it's not 100%, but typical parts of hallucinations and how to detect them. What you can use in building hallucination detectors for your systems. Another important part of LLM evaluation is arenas, right? How to select the best model out of many ones, and it will be also important for many companies using LLMs, right? Because you have now 400,000 LLMs on Hugging Face. Of course, you're not going to compare all of them, but if you consider LLMs which are suitable for your task, you will get several dozens, right? How to compare them? Also within your company, you have multiple LLMs being developed by different teams. Which of them better, or even how to evaluate different versions of the same LLM inside, right? You did fine tuning, you did instruct tuning. Which of them will work better, right? And arenas is one of the another methods which is quite good to evaluate. It's very different principles. What you do here, you ask the same tasks to multiple different LLMs, you get answers, and then you use as a human response, or sometimes you can use again other LLM to compare them, and you consider each task as a game, right? And what you want to predict, given a particular game, which LLM will win. Of course, you rank LLM by kind of quality, or which of them is better player. And you want to use LLM which will be better player, right? Because it will win most of games versus other LLMs. As example, you can go to chatbot arena for generic user task, for negotiation task. It's good paper from Cohere when they describe what is good, what's bad about tournaments-based tasks. And again, arenas will be useful not only for big leaderboards like Hugging Face, but also evaluation of many models, version models within your company. Results of evaluation easy to interpret and possible to modify task, make results more interpretable. I think another kind of coming from Arena is coming model versus model evaluation. No, you don't necessarily build arena for multiple models, but you have two models, you want to compare them, right? What you do, and you ask the same set of tasks for two models, and then you go analyze their output, which models wins. It's very important this for frequently when you want to launch a new version of your model. As you improve this, you want to understand how much it wins, how much it loses also, in what cases, and it gives you very deep understanding of what this model delta, how it will be in particular for your system. It's already supported. Google understand very well this side-by-side experiments, how important them. It's supported by Google Vertex AI, but it's not necessarily use Google Cloud. So most probably model versus model evaluation tools will be used for you and will be very productive for your science teams to improve your models, to build your own evaluation. And how to build this, like tools, right? Again, the tools are really important. Speed, scalability, how fast run your evaluation tool. If you put like 10 times more GPUs, will your evaluation task will be 10 times faster on your model, or your tool does not change. Use it to use code base. Now, none of these tools will be fully ready for your task. You will need to modify them. Availability, easy to add new models, new tasks, new data science. So harnesses are complicated products. You can start building them on your own, but there are a lot of good things built outside, right? It's good to use them as open source, and they're very valuable. Like Letter AI, LM evaluation harness, very powerful on OpenAI evals. For code evaluation tasks, there is Big Code project, LLM Evaluate, part of MLflow, Mosaic ML Composer, now Mosaic part of Databricks, so I don't know what's their strategy for this. Very good, very scalable to multiple GPUs. Or Argus, which I described, Trulians. There are many other tools, kind of giving brick, like Letter AI, perhaps one of the most probably good to use for you. Hugging Face leaderboard uses this. Very well integrated with many open source libraries, tools, like if you want to scale, if you need to go to adapters, using so it's very well supporting a lot of open source and integrated with this. Widely used and tested by NVIDIA, Mosaic, ML, Cohere, Hugging Face, scales well with multiple GPUs, supports many LLM inference platforms, easy to create new zero, a few short tasks. Coming back, so I'm close to the end. LLM in production, right? One is scientific metrics to evaluate an LLM quality, but of course it's really important to will LLM work well for your production with your production requirements, right? It can be let's say latency through output of your system. There may be very different requirements how you want to test your LLM. Is it serving system? Is it batch processing system? Is it streaming system, right? You may need to process 1 billion pages per day. How much, what price you can do? Will it produce inside a certain period of time with certain number of computer nodes you have, right? So how to handle LLMs, because models are big, require a lot of GPUs, and sometimes you can do CPUs, but requires hardware to serve. What about your LLM? Will it serve your task, your customers, right? And typical task, what you use, of course, total latency, total number of tokens per second generated across all user and queries, time to produce first token, what's the kind of first response user get, how fast it produces the whole response. You have certain, typically humans understand around 200, 250, up to 300 tokens per second. Will you match the natural human speed of reading or not? Latency can be that is your latency of the system is good. And of course, LLM latency will be bottleneck on the whole system latency. Operational metrics, GPU utilization metrics for you important as you look into cloud costs. So there are a lot of costs, a lot of optimization tricks now at different levels of both distillation of LLMs up to better allocation of GPU resources, better allocation memory, deployment. There are a lot of tricks how to do cheaper cost of LLMs in production. End-to-end evaluation is the most important. Not the most, but one of really important, right? As you have LLM system and you have all your customer of business, what engagement rate, what response rate, what negative response rates, typically measured by one on another experimentation system on top of your system. It can be A/B experiments. There are many other types of experiments, contextual bandits, so on. But it's important to measure and build as part of your whole evaluation set, easy to build and so on, right? For session metrics, it's one of the key parts of evaluation of your LLM systems. So thank you very much. We had question answering. Yeah, I would be happy to answer any of your questions. Thank you very much for me.
Yeah, we have a lot of questions. I will share Slander and we will answer for them.
Dmitry, are you going to tell the question? So I don't see. I have my
slides.
Yeah,
I will share. Yeah. So for now we will see them, but I will help you to moderate and ask the questions. First question about share the presentation. Yeah, I think we will share the presentation after this webinar, so all will have the access to this presentation, to the slide of this presentation. Okay, next question about which LLM evaluation framework would you recommend? We have a lot of you tell a lot about a lot of frameworks, but maybe you can select some best of these frameworks.
Yeah, I think like kind of if you consider overall, right? I think Aleator UI pretty much leading, both from the flexibility, like task you can do there, how much it can scale, right? Like there are a lot of very positive qualities of Aleator UI compatible with a lot of software you have, right? Again, it may depend. Like if you're like if your team works in MLflow, for you maybe more easy to use LLM Evaluate because it's part of that package. But I think kind of overall leading, and again, it's very well supported, used by many companies. Aleator UI is pretty much on the top. And then, of course, coming for particular task, right? If you want to evaluate Ragas system, right? Ragas is good, like open source to be used on that. Then like embedding tasks. And what I mentioned, there are more like kind of LLM evaluation task frameworks evaluated for particular subtask like Ragas. There would be good examples. But overall, kind of set of tools to start building your evaluation, I think Aleator UI leading pretty much. I heard good words about OpenAI. I did not personally went deeply there, did something, but did not really what I understand. Aleator UI pretty much winning as a kind of whole comprehensive set now. But again, there are multiple different tools, again, based on your condition. LLM Evaluate for MLflow if you use. Composer is scaling pretty well, but it was before better than Aleator UI. Aleator UI doing scaling on own. Again, like particular targeted tools like Ragas or MWeb also there.
Okay. How would you evaluate explainability of LLMs?
What property? What?
Explainability.
Explainability. So how well do you explain the answer, right?
How would you evaluate?
So explainability, like basically the question cat LLM explains the answer, right? I think would be like again, like you can see like recommendation. I mentioned paper about recommendations. That's what they do there. Like it's for recommendation task created by LLM, cat it explain answer. It can be more generic framework, right? Like like what I see, like for a task which you create LLM, right? You have your certain prompt to create the task, and then you need to create a second prompt which asks LLM to explain task. Is it good explanation or not? For me, it would be interesting to check. I see now most probably like human or rated explainability, such that given LLM, given a task it created, given explanation of LLM to ask human to rate explainability, right? Perhaps would be the method I would use now for generic LLM task. And again, like for particular LLM task for recommendation, please look into that paper. They have pretty good framework how they rate explainability of recommendation. And I think it's also quite generic to be used for many other LLM tasks when you need explanation.
More interesting question about how to add. How do you add a custom dataset to MTB?
To MWeb, right?
MTEB.
MTEB, sorry, MTEB.
in tip.
Yeah, I don't remember. I remember that you can add there. Like, I don't remember particular like calls now, but I remember it's part of that such you can add your data set there.
Okay. What do you think about of LLMs-based evaluation of LLMs? So, what do you think about evaluate LLMs by LLMs?
Evaluate LLMs by LLMs.
Yeah.
Like, certainly, I see it will be one of very big parts of LLM evaluation, right? Because again, like once you go to human annotators, you need to scale, you need because typically to evaluate a lot of tasks, you need a lot of evaluation tasks, you need a lot of tasks to ask humans, right? You need to build big evaluation force. First, it's expensive. Second, it requires time, right? As you're a scientist, you have a new version of LLM. You want to evaluate this against certain task, right? And unless you have very big first annotators, sometimes in May, like you have a result of experiment, you need several days to get the result back. And with LLM, you can get maybe within a very short period of time, right? Based again, like what's the output you build for that. So certainly having LLMs for evaluation has a lot of advantage for many, many tasks where they work. They don't work for every task again, but they work for many tasks. So certainly I see LLM-based evaluation of LLMs will be a big part like of any LLM evaluation in any company, because yes, they actually do well for a lot of evaluation tasks. Like for example, when you don't need to go to external ground truths to compare, right? Or when you don't need to do some common sense reasoning, when you just need within this text, like you have information extracted, answer from this text. Is this answer truly from this text or not? It's just purely textual reasoning. And LLM does this very well, right? For verification, for evaluation. And certainly I see in companies, and so it's like not just some abstract academic, it will be used almost every company. I see LLM being used for LLM evaluation task will be a very big part of toolkit of any science team developing, improving LLM and LLM-based products.
Yeah, I understand. And how about evaluating multimodal LLMs? I think you not tell about this today.
Yeah, I did not touch. It's a very big area, right? And again, as you see, not only about LLMs, about whole foundational models, right? You see the same patterns, that the same model will be used by many different teams for many different tasks, like time series would be one another hot topic recently. Certainly, kind of, when you go to multimodal LLMs, the task becomes even more complex, right? Because first you have the same pattern of usage, right? Such that, and potentially they will be used even for more tasks, because almost, of course, not like there is a lot of intersection between use cases and products, LLM, multimodal LLMs versus LLMs, but there are a lot of discrepancy, right? But there are a lot of tasks when like for traditional LLMs, where multimodal LLMs applicable and produce better results, so you want to use them, so you inherit all evaluation for those tasks. But there are many other tasks for which you will use LLMs, right? Multimodal LLMs, and suddenly evaluation becomes much harder, because you have like let's say you have a question, right? Query for item, and for these items you have only images, you don't have text. Is it a good extraction? Is embedding representing this item, and then you have embedding, like which I use both text and image modality, and then you have query which represents only text modality. Is it good embedding too much or not, right? Like just particular example. And how to evaluate this? It becomes much harder to evaluate the quality of this embedding, which you use also image modality, right? Certainly, like what I see, like you need to build a lot of this evaluation tools for multimodal models, and I expect what I see, certainly evaluation of them becomes harder just by naturally. It's much harder to understand once you go, and of course it may be other type of modality, can be audio modality, right? You have let's say phone calls for your company, for customer support. Image modality is one, but you have also maybe a model which takes an image, and then how to evaluate right extraction from images becomes much harder, right? Sorry, not from audio also. So I see, like, I think almost every LLM evaluation task will be in one or another way inherited by multimodal model, but they will have also a big set of own evaluation tasks, and some of them are harder to evaluate, especially when you go to human-based evaluation also, right? So yes, should be several talks because there are many things coming there, many different evaluation tasks which are not present in LLM, and they are also quite harder to evaluate. It will be a very big area, but very important area because audio modality, image modality, video modality certainly relevant for many businesses, many products. Very important to you can get a lot of new customer experience using LLM, like multimodal models for them. But again, you get into evaluation problems.
Yeah. And which team should do the evaluation of the model, and in which environment? In production environment, or it should be some additional environment where this team are working?
Both, right? Like one, multiple. Why do you want evaluation, right? First, you want to help your science teams, which works on LLM improvement, to be as fast as possible to run new LLMs, to create new versions which are better for this company. And of course, here comes a lot of iterations which your scientists will do, right? And how to enable them to do this iteration as fast as possible. It will really help them to find the best solutions. And for this, you don't need to have whole process to having the working versions of LLMs to be deployed in production. You want to enable your scientists to have very fast, I have new idea about like other new fine-tuning techniques or about new data sets, fine-tuning or something else. There are tons of ways how to do, or you distill your models, you want to find more efficient, how to test them, right? You want to enable them to do the iterations as fast as possible, as easy as possible, as scalable as possible, both by number of models, both by number of people, both by data sets. And for this, you don't want to use your production environment. You want to isolate this with your science team such that they can run it as soon as possible. So you need the development science environment to do very fast iteration of their models. And of course, once you have a model which is very good candidate for production, right? Then you need the second step. You need to see how your model will work with production data, like how your model will work. Production data you can go into the inherit into development environment in many cases. But you need to work how your model will be performing against in the production task, right? In that case, you need whole testing, pre-production testing, and production testing. But certainly, what I see in multiple environments will be a necessity, just because you want to give a very good environment for your science team to work, test, maybe as fast as possible, as soon as possible, with high quality as possible. That's why you will need an environment for them separate from your final production. But you will need certainly production environment because at the end your model will be there, and you need to test it against production environment, against your customers, and so on.
Yeah. Thank you for your answer for this question. We are a little out our time, so we will continue answer for the question in Slack. So thank you for all that you was with us. Thank you, Andrei, for this amazing presentation and overview of different practices, technique, and frameworks which engineers can use for evaluating LLMs. Yeah.
So thank you very much, everyone. Yeah, I will have a little break. I will come back to Slack a little later today, so I will be answering, but offline. Thank you very much. Thank you, Dmitry, for inviting me. Thank you very much for, it was a big honor for me to present here. Thank you.
Yeah, thank you. See you on the next webinars. We will announce them shortly.